Mais um dia, mais uma live, começando aí, live dia 73. Eu tô bem zoado da cabeça, eu tô bem doente. Eu saí do hospital agora, eu tô com cordãozinho até do hospital. Então hoje eu vou tentar fazer uma live, apesar que todas têm sido curtas, né? Mas hoje realmente não vou conseguir me estender muito. Queria abrir live mais cedo, mas. Ontem a gente deu uma olhada em callback, né? Que eu acho que é uma coisa em JavaScript, né? O jeito de escrever código em JavaScript, pelo que eu entendi. Mas ele não é uma função pré-estruturada no Java, né? Então, o jeito de fazer callback é com if e else mesmo. E a gente passa um parâmetro que é um. Como é que chama isso aqui? É uma functional interface como parâmetro. E aqui eu tô passando para a função receber como parâmetro firstName, que é outro parâmetro também. Então, aí aqui eu passo a definição do que a function interface vai fazer, né? Que ela vai retornar. No caso, é um consumer, ou seja, o consumer ele não. Pera. O consumer ele não retorna nada. Ele, ele recebe um parâmetro, que no caso aqui é uma string e tal, e ele não retorna nada. Então, o que ele vai fazer é só lançar um system out print ln para falar que não foi encontrado o outro name. E dito isso, a gente termina a aula aqui, a gente vai ver lambda primitive. E eu acho que não sei se dá pra terminar hoje, mas se não der, dá pra gente terminar o lambda aqui.
Lambdas. So let's go ahead and expand this. So command and then 1. And right here for this main method, let me go ahead and simply name this as callbacks. Just like that. Now let's go ahead and create a new class and then simply call it as lambdas. There we go. Oops, not lambdas, but lamb and then des. Just like that. Now let me collapse that and then public static void main. Now inside, let's go ahead and have a function. There we go. That takes a string and returns a string. There we go. So let's simply say print and then name equals 2. So this guy will take name, and then right here, so this part right here, it's a lambda, right? So this is a lambda where this is the actual argument, right? So this name right here is what comes from this data type. So right here, then you have to pretty much just do the following. So if you have only one line, so if you simply return immediately, you can simply do this. So south, and then, well, actually not even south, my bad. So you can simply and this is not a good example, so not print name, but let's simply say upper and then case name, for example, something like this, right? So now right here, if you simply return immediately, you can simply do this. So name and then dot and then uppercase, right? So you can immediately do this. So this is only when you have one return statement right after this arrow right here. So because you only have one return statement, and you can even see that IntelliJ is telling you that you can use method reference. So this is because right here, this is the same as doing this, right? It's the exact same thing. So this is more understandable, but you know, once you get to this is the same as doing method reference. So this is because right here, this is the same as doing this, right? It's the exact same thing. So this is more understandable, but you know, once you get too comfortable with this, you'll start to use code like this. Now another thing is right here. So if you have to do some extra logic and not return immediately, you need to have these curly braces right here. So now you can have a logic, right? So you could, for example, say if and then name dot or actually is blank right here. So if it's blank, then you can throw new illegal and then argument exception, something like this, right? And then right here, otherwise now, because I need to return, I need to say return and then name to uppercase, but also I need to add semicolon right here, right? So you can see that now this is the actual method body for this lambda, right? So this lambda, so this is the entire thing right here. So another thing that you could do with lambdas is, you see right here where you have name. So if this is a by function, so by function, just like that, and then right here let's simply have let's have an integer right here, integer, and this will be age, right? So now you see that I need to put age right here because this data type is for this one and this data type is for the second one, right? And string is what this by function returns. Now because I have two arguments, I need to do this.
Pô, mas ele tá ensinando isso nessa altura do campeonato? Ele devia ter ensinado isso aqui antes, né?
In these parentheses. So let me actually go back for a second. So right here, so where we have a function, so you see this is a function, I can even, you know, enclose them with parentheses. But because I only have one argument right into this function right here, I can simply ditch this, right? But if you have a by function, and right here let's simply say integer again, and then age, now you need to enclose like that, right? And you could, you know, do something like another logic right here, so south for example, and then age, something like that, right? And you know the way you'd use it is as follows. So uppercase name dot apply, and then Alex, let's have Alex here, and Alex is 20, right? There we go. And this returns a string right here, upper cased name, and then south, and then uppercase name. I can even inline this like so. If I run this, there we go. So 20 and then Alex. So basically this is this logic doesn't really make sense, but I just want to show you exactly different ways that you can use these lambdas right here. So if you have any questions on lambdas, go ahead and drop me a message. Otherwise,
if name is blank, throw new. Tem outprint ln age, return enter, uppercase.
let's move on. All right, so just to let you know that I think I didn't mention this at the beginning of this course, but when you use these functional interfaces, you see right here where you define the actual inputs and outputs of functions, right? So string and an integer and then string. So these right here, they have to be the object type and not the primitive. So for example, integer, right? So you could have an integer like this. So integer and then number equals to null, right? And then you can also have integer and then let's say counter. And right here, I can't say this. So this is invalid, right? Because this is a primitive version of this object type right here, right? So right here, you either have to say a number. So it could be negative number or positive number. So if I do a 0 right here, you can see that this goes away. So for that reason, you are not allowed to have primitives in here, right? Because if you have to pass nulls, then you can. So with primitives, you cannot. So right here, you see that we have this integer right here. So I can go ahead and simply say null right here. And you see that works. But if I was to have this integer, so the primitive type, that does not work. And also, one thing that I've been doing a lot throughout this course is having static right here. So static. So the reason why I've been doing static is because I'm outside. So right here, I'm outside of the main function, and the main function is static, right? And you can only use static methods inside of this main function. So right here, you can see that this still works, but if I remove the static keyword, you see that it does not work, right? So this is something that to bear in mind. Your functions and by functions, they don't have to be static, right? In fact, having static throughout your code base is not practical. So ideally, what you would do is simply have, for example, so let's say that you have a class. Let me actually put this inside. So just like that. So let's say that you have a class and then call this a service, for example, right? What you should really be doing is like having, publics and then your function, for example, or predicate or consumers, right? So consumer of string and then blah equals to and then s, right? Just like that. And then basically this is your public interface. You can also change this to private or no access modifier at all. So this is package protected, right? So just to bear in mind that they don't have to be static, and you should avoid static. But the reason why I've been using static is because I've been doing everything inside of this public static void main method. So there we go. If you have any questions on primitives and the use of static keywords, go ahead and drop me a message. Otherwise, catch me on the next one. All right, let me go ahead and quickly show you the rules that come with functional programming and everything that we've learned throughout this course. So the first thing that you should know is that there should be no state around your functions, right? So the functions, they have to be pure functions. So they shouldn't depend on any other state. So for example, if you have a global state or a global variable, your function should not depend on that global state, right? So that's the difference between pure and impure functions. So pure functions don't depend on global state. Impure functions do depend on global state.
O que é global state?
And that comes with the side effects, right? So your functions should have no side effects other than everything inside of the body of your function, right? It shouldn't have a side effect outside of the function. And also higher order functions. So a function is considered to be higher order function if one of these two conditions are met. The function takes one or more functions as parameters. So we saw how to pass functions inside a normal functions, right? Or if the function returns another function as a result. So with the combinator pattern, that's exactly what we've done. So let me actually show you. So right here, so with callbacks, so right here, so you can see that right here we are passing a function right here. So this is a function, right? And also within our combinator pattern, so remember, so customer and then registration validator, check this out. So right here we are returning a function. So this interface extends customer, or actually extends function that takes a customer and sends a validation result. But if you check the return type of all of these methods right here, so if I do a command shift and then minus, you can see that they all return the function right here. So this means that we are satisfying with this property, higher order functions. So
então ele é high order function se ele tem ou mais funções como parâmetro, ou se ele retorna outra função como resultado. Que doideira, eu não lembro de ter visto uma função que retorna uma função como resultado. Mas aí, tipo, se eu quiser fazer uma função que retorna uma função como resultado, eu teria que colocar como function. Tipo, em vez de colocar, sei lá, integer ou string ou, sei lá, qualquer outra coisa, eu colocaria function como o tipo dela. Ou by function, whatever.
Make sure that, for example, let me actually show you, the no state and pure functions inside effects. So if I go back to, let's say, lambdas right here. So you see this function right here. So int by function right here. So I should never depend on, for example, counter. Right, so let's say that I do, for example, south and then counter, or if I change the state of counter, right, I should never do this because it will break all of this, right? So you see that there might be some side effects on the outside of this function right here, right? So outside of this function, there might be some side effects. Also, you see that you are now mutating state, and it's no longer a pure function. It's an impure function because it depends on global state. So you never want to do this. Or for example, increment the number. So number and then increment plus plus, something like that. You should never do it, right? So your functions right here, they should be self-contained, right? So they should only depend on the state that you define inside. So right here I could say int and then counter equals to 0. So this is absolutely fine, right? Because this counter, so this counter right here, it's only visible inside of this function and not the outside world. So if you have any questions on these properties, go ahead and drop me a message and I can give you more examples. But this is pretty much everything you need to know about functional interfaces and functional programming with Java. If you have any questions, go ahead and drop me a message. Next, let's go ahead and wrap up this course.
Pô, que curso bom, cara. Pô, que curso bom, velho. Deixa eu ver o resumo dele aqui.
Okie dokie, amigo. I want to congratulate you for completing this course and practicing throughout. So, as you saw, for you to write functional programming, you just have to shift the way that you think. You no longer think about regular Java functions, but you start to use functions, bifunctions, predicates, consumers, suppliers, so on and so forth. Now, the next step for you is to enroll to my course on Java Streams API, because once you combine everything that you've learned in this course with Java Streams, you will start to write code that really shines. Instead of you writing code that takes, for example, 20 lines of code, you'll simply take 5 lines of code with streams and functional interfaces. So this is all for now. Go ahead and subscribe to my channel to get more videos like this, and it really means a lot to me to see a lot of you, sending me messages.
Pô, tem que dar uma olhada melhor em strings, cara. Strings é o que? Pô, que aula boa, mano. Muito boa, muito boa. Eu queria ter dinheiro pra comprar o curso desse mano. Muito boa. Cara, eu não consegui fazer essa revisão aqui. Eu vou colocar pra colocar ela amanhã. Amanhã, assim que eu acordar, eu vou fazer essa revisão aqui. Tá. E eu posso rever o curso todo. Rever entre aspas, né? Tipo, dar uma olhada em todos os tópicos, né? O que a gente pode fazer agora? Eu acho que agora a gente pode ver o que a gente vai fazer depois, né? Vamos dar uma olhada no... Aqui tá, já tá aberto já. Tá, então aqui nesse mapa a gente tá... A gente já viu tudo isso daqui. Eu acho que agora seria interessante a gente dar uma olhada em Spring Boot, né? A gente dar uma aperfeiçoada em Spring Boot, procurar um curso, alguma coisa de Spring Boot pra gente fazer. Tem aquele projetinho que a gente tava fazendo do fiasco. Deixa eu fechar o meu Discord. Aí. Tem aquele coisa que a gente fez do fiasco. Mas eu não sei, eu queria achar... O que eu posso fazer? Eu tava pensando em ver se eu estudo banco de dados, né? Mas não sei. Tô orgulhoso, mano, que a gente chegou relativamente longe. A gente pode ver um pouquinho disso daqui, né? Que a gente não... Sei lá, não vi... Eu vi... Eu vi módulos? Não lembro se eu vi módulos. O que é um módulo? The role benefits Java developer will the biggest result. Report of rejection, upload APIs. Tá, não, o que é isso? Ah, é isso aqui, né? Eu lembrei, eu vi isso daqui. Que você escreve ali a inversa, pá, não sei o que. Eu lembrei, eu vi isso daqui. Agora que eu vi o optionals, né? Dependência injection. A gente pode dar uma olhadinha nisso daqui, né? File operations eu já vi, acho que a IO operations não. Deixa eu dar uma olhada em dependency injection. E depois partir pro Spring Boot, se pá. Cara, acho que minha gata fez merda. Eu vi um barulho dela lá fora. O que a gente pode fazer aqui, hein, velho? Tô curioso. File operation a gente já viu que é possível. Release, set map, que stack iterator, generic collection, já viu tudo isso. O let keyword, isso aqui a gente não viu, né? Concurrency. A habilidade do programa de executar múltiplos testes, isso aqui a gente não viu. Ou se viu, viu muito por cima, né? This doesn't mean that running at this exact same instant, but rather than execution overlaps in time. This can be achieved through techniques like multithreading, where a single program is divided into multiple threads that can run concurrently, or though asynchronous programming, where tasks can be started and then the program can continue executing other tasks without waiting for the first task to complete. Legal, legal. Cara, eu não gosto desse site, mano. Não gosto desse site. Não gosto mesmo. Esse aqui eu gosto mais. Java Concurso Service Series. Java Concurrence. Java de concurso. Será que não tem uma videoaulazinha? É o Concurrence? Concurrence. Será que é esse multi-thread aqui? Acho que eu posso deixar ele pra ver ele amanhã.
Now I mentioned there were two. In this video, we're going to talk about how you.
Amanhã eu dou uma olhada nele. Por enquanto eu vou sair fora. Eu sei que não bati os 25 hoje. Mas não tô muito legal. Tô sem comer o dia inteiro, não comi nada. Tô com dor de cabeça. Eu vou sair fora. Obrigado quem acompanhou. Obrigado quem assiste depois da live ter começado aí. Amanhã, como sempre,